So our slope equation becomes EI dy by dx is equal to 1214.29 x square by 2 minus 4928, which is C1, and C2 is 0. So we have this first partition, minus 2000 into x minus 2 square by 2, second partition, plus 1500 into x minus 4. Also, our deflection equation will be EIY is equal to 1214.29 into x cube by 6 minus 4928x plus C2, which is 0. So we put this in first partition, minus 2000 into x minus 2 cube by 6, second partition, plus 1500 into x minus 4 square by 2. So we have got our slope and deflection equation. So we can move towards to find out your deflection at point C. Now we see that point C is at distance x is equal to 4 meter. So by substituting the value of x equal to 4 meter in your deflection equation, we can get the value of yc, which is deflection at point C. So now we find out your yc. Now putting x equal to 4 in deflection equation up to second partition, since we know equation up to second partition is valid between point B and C. So we have EI into YC is equal to 1214.29 into 4 cube upon 6 minus 4928 multiplied by 4, first partition, minus 2000 into 4 minus 2 cube, the whole divided by 6, second partition. So the only unknown in this equation is a yc. Since we know your EI is a constant, so we can get the value of yc as minus 9426.24 upon EI. Now if the flexural rigidity EI is in Newton meter square, so we'll get a deflection in meters. So this is our answer. Now if suppose the value of EI is given as E is equal to 200 gigapascal, so this will be 200 into 10 to the power 9 Newton per meter square, and I, which is the moment of inertia of the section of the beam, is 200 into 10 to the power minus 6 meter to the power 4. So we will have the value of yc equal to minus 9426.24 upon 200 into 10 to the power 9 multiplied by 200 into 10 to the power minus 6. So this will give the value of yc as minus 0.23 into 10 to the power minus 3 meters. So if we take this deflection in mm, we'll have yc will be equal to minus 0.23 mm. Now since this deflection comes out to be negative, we see that the deflection at point C is downward. So now if we see the elastic curve of this beam, which is also called as a deflection curve, which is caused by this forces uncouple, the elastic curve or deflection curve will be something like this, and we see that a deflection at point C, yc, is equal to minus 0.23 mm. Thanks for watching in 5 minutes.